include winning the Block Hack Hackathon BSc in 2016 and setting up ETH Mumbai community for spreading blockchain awareness. Blockchain is one of the hottest and fastest growing skills in the IT sector today. We all know that this technology has taken quite a turn in the industry given its popularity in providing safe and secure online transactions. So we are very pleased that you accepted to take this session and hope today will be a turning point for all of us. Okay, so sir, and I welcome you to take the session. So I think your audio is switched off.
Hi. Hi,
Okay.
everyone. How are you doing? Um, yeah, today's topic we'll take is blockchains. Now, in the chat, can everyone let me just quickly know how many people have heard about blockchain and how many of you have actually worked on a bit of, so I get understanding of the level of knowledge which everyone is at, um, and have played around with just heard of it. Okay. Anyone who have like gone a bit deeper, or everyone just heard about it that it's a new technology, something like that, or everyone has just heard about it? Just give your feedback in the chat. Okay. Okay. And what all you have studied in terms of cryptography or crypto systems till now, encryption, decryption, public key crypto system, and what all have you studied in economics? Because blockchain is a mixture of economics and crypto systems that comes from the security domain. Uh, Now, what makes blockchain that interesting? Let's go to that question first. Why the world is mad about it? World is mad about it because before I go into the technicals, let's feel free to ask any questions if you have any. And sorry for my cam. I don't have the cam on my desktop, so I will not be sharing. I'll be on the cell phone. Um for video. And uh, coming back to the original question as to what makes blockchain that interesting. Blockchain is a mixture of two technologies. We have the crypto communication technology, and then we have then we have the economics part of it. That you have applied crypto systems to money and to the knowledge of money coming from economics. Then you have something like Bitcoin or blockchain that is built. Now, if you have taken your economics class, then you would have learned that in economics, there's a concept called as money, which everyone loves so dearly. And if you want to take that money on the internet scale, or if you want to take the concept of money onto the internet, we need security that my money should not be stolen by anyone. Okay. Uh, And if my money is not to be stolen by anyone, in that case, what happens is I need security for it. And I need to apply the principles of economics onto the principle of economics using the concepts of security in such a way that my money should not be stolen, but everyone should know that my balance, I know have this much amount of money. So that is universal knowledge that everyone knows that what is your balance. And that is the fundamental reason what gave rise to Bitcoin. Initially, there were some experiments done by various governments, various private institutions over how can we get money on the internet. PayPal is one example of it. PayPal is one example of it. Hashcash is one example of it. But this was in early 2000s, wherein money was experimented on the internet on a very primal level. You can have one day. Now, what makes it more different than the other definition of money, like bank? What makes it different than uh, the the banking money. Banking money is the money that is in the bank is kept within the servers or the database of the bank, and a bank can inflate its book, can do some mischief with it, and you can have an accounting problem over there. But at the same, and because of these problems, RBI and other such agencies have set up a set of rules and guidelines for everyone. Now, what sets blockchain apart is in banking system, since everything is inside one database or multiple databases, what happens is you need to adhere to the rules of the people. You need to adhere to a human rule. But if you have blockchain, then blockchain takes care of the rule management engine across multiple parties at the same time. So let's say five banks come together and say that, okay, we will launch our own money which will adhere to the banking requirements. They can, and that would have that has given rise to something known as wallets that we all of us use. So how many of you have used Google Pay or UPI or any phone pay or any such apps? Just a quick poll. Um, okay. So Google Pay is a classic example of a next generation payment system wherein instead of holding that database, we have a reconciliation system that is based on a blockchain kind of system at the back, and that entire network is created by NPCI, that is National Payments Corporation of India. Okay, so NPCI will give you the interface to talk to the banking system, and that interface can be used by any of your wallets, and your payment systems can be eased down or very simplified by that virtue. You will agree that paying by Google Pay is way simple than paying by uh, cash. Okay, so this just being the introduction, uh, let's jump down into the Bitcoin part of the system. I'll just share my screen. Just share my screen to show you what the blockchain resembles. Can you see my screen, guys? Can you see my screen? I'm sharing my screen from my other system. Okay. So in blockchain, there are three components. First one is block explorer. Blockchain.info is a block explorer. So blockchain, the block explorer is one. Then I will show. Then we will go on to just a second. Get it loaded. So this are like, okay. So each Bitcoin address, or in the Bitcoin network, what is your identity? Just like in Google, you have your email as an identity. In Bitcoin network, your identity is represented by your address. This is my wallet called MetaMask. This is for Ethereum blockchain. We will come to Ethereum blockchain in a point in time. But let me show you an example of an address. This, what you see, account 0x44, that is your address. In the same way, I can see that I'm having some testnet ether on my wallet. Uh, so this address in Bitcoin looks something like this. Keys.lol in Bitcoin address looks something like this. This is the address. This. This is the address of the person. This is the identity of a person on the Bitcoin network. A person had received 1.4 Bitcoin, and then he has sent this much amount of Bitcoin, and the final balance is total is net zero. Okay. So this is about Bitcoin. In a similar way, you have various wallets, various other blockchains which will have different types of wallet addresses. All Ethereum addresses will start from 0x44, and all Bitcoin address will start from 0113 or B or something of that sort. So now what is this address? This address is something known as ECC crypto. So this address is nothing but a point on this graph curve. That address is nothing but a point on a elliptic curve graph curve. Okay, let elliptic curve graph looks something like this. Elliptic graph looks something like this, and you have a point P, which is your private, which is your public key, and the number that you have multiplied it with is your private key. Private key you don't expose to the public, and the public key is exposed to the public. So this point is on a coordinate geometry. You will have a point will have x and y axis, and based on that you can determine your address. So address is a function of your public key on the elliptic crypto system, and using your private key you can sign the transactions, and when you sign the transaction, a transaction hash is generated that you are sending money from your account to someone else's account. Okay, so this is the basics of this is just about the address and the transaction in the Bitcoin blockchain. Now what happens when a transaction is broadcasted? A transaction is broadcasted. When a transaction is broadcasted, you have some set of miners in the Bitcoin world, and these miners, let me just go to the mining page. These miners will aggregate, just a second, Bitcoin mining. Okay, so you will see that there are some currency statistics. No, hash rate distribution. So in Bitcoin mining, what happens is all the transactions across the world, Bitcoin transaction visualization. So whenever a Bitcoin transaction is broadcasted, so this transaction broadcast, what I mean by it is broadcasted to number of nodes that are out there on the network. These all nodes form a peer-to-peer network, just like a BitTorrent network. You are broadcasting money, you are broadcasting the transactions onto this peer-to-peer network, and the miner node will listen to all such transactions, and you can see that at this moment there are these many transactions that are being broadcasted at a point in time. So there are some transactions that are happening from Russia, there are some transactions happening from Norway, US, India, China, Japan, everywhere some or other transaction would be happening. Okay, these transactions are listened. The miner node will listen to the all such broadcast and compile a block. This block, miner node will compile a block and send that block on to just a second. Yeah, miner node will compile the block and send it to the all the nodes that okay, I have mined it. I'll do some computation. I'll come to the proof of work over here. I'll do some computation on it and broadcast it to the network. If every other node agrees to that particular block that has been broadcasted, then the miner gets the fee. Otherwise, the miner will not get any fee. That is 6.25, and that is what all the mining. When anyone talks about mining, it means that they are fighting for this block reward. That is 6.25 Bitcoin. Earlier it was 12.25, but as difficulty grows, the amount of mining is like you do a lot of effort, you get nothing. So that's why mining is no more interesting at this point in time. So a block consists of all the newly generated coins and all the transactions that are assimilated in that particular block. And there's one other interesting thing. You can see there is fee that is aligned to all of these transactions. These fee, the sum of all of these fee is given to the miner. That okay, you there are some amount of fees that are all of these fees will go to the miner. The sum of all the fees will go to the miner, and that is the another source of revenue for the miner. So this is basically all about Bitcoin in a gist. Do let me know if you have any questions. It would be really nice if you post some questions because the session would be really interesting then on. I'll just wait a second. Okay, let me rewind it for you. I'll show a minor example in Ethereum blockchain. So whenever someone is doing a transaction onto the blockchain, you can see the transactions are being broadcasted. This the lower left part shows the transactions that are broadcasted by the people. Everyone who is having Ethereum on their account, they will broadcast it to the network, and the miner node will pick some transactions from this pool, that is the this pool over here, and they will broadcast a block. Each block will take some of this transaction inside itself, and this block it will be compiled by the miner, and miner will do a proof of work algorithm on top of it. Now, what is proof of work algorithm? Proof of work algorithm. Uh, Proof of work is a consensus mechanism wherein you have solved, let's say you are given 10 minutes of time and to solve a problem, and what is the proof that you only have signed it or you only have completed that problem? You have to go and do recursive hashing of your work, of your hash, till you align to some amount of zeros, and that a number of zeros is denoted by difficulty. So as and when the network progresses, as and when the difficulty as and when the miners are added, the difficulty increases to mine, and as and when the miners are removed, the difficulty decreases. So the amount of zeros that are required by the algorithm keeps on varying automatically based on previous history. So this is proof of work, and when the proof of work is achieved, a miner will attach it to the block, block header, and broadcast it to everyone in the node. So now everyone in the network. So what happens when you broadcast it? As you can see over here, there are multiple nodes that are sitting across the world. Now there are some static nodes over here who are constantly up. Now these nodes will decide whether the transaction is to be accepted or rejected, or the block is to be accepted or rejected based on timing. So if I send a block number 1000 right now, my block is bound to be rejected because 1000 right now the consensus height is this much, but the block number is 1000, so obvious rejection. But now if I send a block number 635535, it would be accepted by few, but it needs a 65534 as precedence. You have to send this block number at this point for the limit of 10 minutes. And the lower bar that you can see is the incremental. This number that you are seeing is how much time is left for that particular block to assimilate. Okay. And this is just an introduction of Bitcoin. There are many more details onto it. The details would include like how do you transact, how do you secure your wallet, how does the consensus works in actuality, what are there are certain edge cases that you may come up with, and how do you deal with that. For example, the edge cases not in terms of the network per se, but in terms of understanding that how did this problem be solved. For example, mm, let's say the block is being broadcasted, but there are two simultaneous blocks that are being broadcasted at the same time. Then what to do? Which one gains the precedence, or which to take and which not to take? So there are some small questions like this, and uh, that needs to be understood. Uh, do let me know if there are more questions on mining, because I'm expecting some. What happens after number reaches 1,000? A new block will be generated. Let's just look at this number itself. When this reaches 100%, that's what you're saying, right? If this reaches 100%, then this consensus height would change, and in the Explorer, we will be able to see a block number, one plus block number. So you see that this block number has increased. So this is running a bit in lag mode at this point. So this is the acceptance part, that you accept this particular block that you are verifying, and this is the current height that everyone is at, and this is at verification. 3 4 is at verification. 6 is the block. 6 is the time that you need to confirm a transaction. Within this time frame, anything can the forking can happen within 6 blocks only, not prior to that. So there is a lack of time at this point, so I'll skip the forking part at this moment, because forking is a complicated concept. How does a block get verified by the nodes? Block gets verified by the nodes based on the difficulty. So the difficulty. So let's say this Merkle root multiplied by multiplied by this difficulty factor, this this difficulty factor and this hash of these two will be this number. This is a simple one function that you calculate within a polynomial time, a simple o log n time, o log 1 time, and you get this value. But in order to calculate this, you have to rotate your sequence this many, you have to rehash this number over this many times. So calculating this number is tough for the first time, but moment you have the difficulty, it is like you have derived, you need to you have derived that uh, you have derived that to calculate it for the first time, it takes a lot of time and effort and computation, but once it is calculated, you don't need more time. So this is how the block is verified. What do you mean by static nodes? Static nodes, there are two types of nodes over here. The first node is a full node, and the second node is a light node. Light node does not store the history of the blockchain, but the full node will store the history of the blockchain. Uh, so static node is something like Bitcoin QT, uh, Bitcoin Core. Bitcoin Core is the node that is like the full node, where entire history of the blockchain, starting from block number 0 till today, will be stored. But in order to for it to sync up, you need to wait at least like a week in Indian bandwidth, Indian broadband speed. You'll have to wait a week to sync it up totally, and the light node is something known as Electrum. Electrum Electrum wallet. So Electrum wallet and other wallets are light nodes, which will broadcast your transaction directly to the Bitcoin network without having, which will just do the transaction, which will just broadcast your your transaction to the network without actually running the full node. So when you and there are some other wallets also which will use some third-party services like BitPay. Um BitPay. BitPay is a service provider. Whoa, what happened? This should not have happened. Where am I from? Okay, I was from VPN. That's why. Uh, yeah, I'll come to that point in a second. Um, BitPay provides you APIs that BitPay will provide you with a wallet and a wallet system or an API system where you can directly sign the transaction on your cell phone, but they will do the task of broadcasting it to the network. So these are some other sites. Uh, and these are like you have full node. Not all systems will not run the full node at all given point in time. The full nodes will be run by some specific nodes only. Okay, and most of the people will be using static nodes, or let's say static nodes or wallets or Electrum or something of that sort, which is like a client side application which broadcasts the transaction onto the network. Why are bitcoins blocked in some countries? Is there any known vulnerability for blockchain system? Right now, the bitcoins are blocked in some countries uh, because of its nature of universality. That it is if you run a full node, it does not matter whether you are sitting in India or US or any part of the world. You cannot control it, and that is the point why Bitcoin is banned in some countries. But despite the ban, the enforcement of the ban is far more important. No one can enforce that ban because it is the people who would be interested, or people. It is the people who are wanting to. Is the people that they are wanting the coin, and so that is why they are blocked. And another reason is there is some element of terrorist funding also associated with it, or let's say illegal activities over blockchain, and that is a concern that if you are the owner of your private key. So there is a legal rule that is applied, and the legal rule is caveat emptor. Caveat emptor. That in case of banking system, you can blame the bank that okay, your system is screwed. My money is held with you, and my system is screwed. The bank system is screwed, where bank takes the liability. But in case of Bitcoin, you are holding your private key. It is your responsibility to secure your private key, and that responsibility comes to the user and not to any middleman. And this kills many businesses in the wake. So let's say if Bitcoin becomes prevalent in India or across the globe or in the entire globe, then what happens is suddenly we will find that why the money is used is not known to anyone. Only the sender and the recipient knows it. However, in order to maintain law and order, we need that system to be in place, that you need to disclose that why have you spent this money, or at least someone who can be kept in private needs to know that why is this money used for, what is this money used for. Does that answer your question? And going to the next point, is there any known vulnerabilities for blockchain system? Uh, Known vulnerability for blockchain system right now, there are few, but very basic. They're not like you cannot have RCE or any such attacks on the system. But the vulnerabilities of smart contracts, which we'll be covering next, or let's say we'll be moving into smart contracts, there is a whole segment for securing smart contract. So that is a different domain altogether. So just like you have web application scanning, you can have a smart contract audit system or something of that can be built on top of it, because that is a totally different domain, and there are very few people whom I know are into that area at this point. Okay, shall we move to Ethereum then? I agree. I'm not doing justice at this point with you by running very fast with Bitcoin. Uh, Bitcoin is each one of this would take a lot of time to understand, clear out the doubts. Okay, then let's move on to Ethereum. So now, Ethereum is one interesting piece of technology. The reason being is let me just go to one Bitcoin transaction. Let's look at this Bitcoin transaction. This Bitcoin transaction, each transaction will have some script that are associated to it, some inputs and index and every values associated to it, output, some values associated to it. Okay, each transaction will have some value associated with it in form of script. In here, these scripts are very basic signaling systems. They will be either binary or something of that sort, but they will not mean anything other than that. Now, the interesting part is, if I were to replace this with a piece of code, with a virtual machine, with a piece of code that is backed by a virtual machine, in that case, what happens is, let me show you an Ethereum transaction. So, in your accounting system, so basically a Bitcoin transaction is like you are doing a ledger entry on your accounting book that I am sending money from my account to someone's account. Now, in accounting system, each transaction can have a set of description or a description field that is associated with the transaction. Now, each of this description field can be anything. It can be anything written in gibberish or anything it can be written in. But now, if I were to put or make a 8-bit machine on the Bitcoin node and keep it on it, and at the same time, if I were to take a piece of code and make it run on that 8-bit machine, EVM. This 8-bit machine in Ethereum is called EVM, Ethereum Virtual Machine. So, Ethereum Virtual Machine is a 8-bit processor that sits on top of your Ethereum blockchain node. Now, this blockchain node can read contract. That has its own, this virtual machine has its own programming language called Solidity, Viper, Bamboo, Serpent, Mutan, etc. etc. The most prevalent one being is Solidity. You write your language in Solidity. The language will be compiled into a bytecode format, and that bytecode would be attached as a description on your transaction to the blockchain. And moment you have attached this bytecode, it will make a contract for you. Okay. So when once it starts making a contract for you, that contract would be sitting on the blockchain. The contract would be sitting on the blockchain, and at the same time, it would have some input parameters, just like a code that you have written in C++ have some inputs and some outputs. If you give it some input that fetch me this particular function that is the input, the output would be the fetched result. The same way, the blockchain would also give you answer to a specific code. So now, why is this required? Now let us just calculate a simple calculator. When you install a OS, a calculator is installed on all of your systems by default. Okay. Now consider the number of OS installations of Windows 10 across the world. Across the world, there would be at least a billion Windows 10 installations. A billion installation multiplied by 1 KB of space, or let's say 1 MB of space. That would mean something like how about 1 or 2 petabytes? 1 or 2 petabytes of storage space just going for a waste, just for running a simple calculator program across all the different systems. Right now, you may not see that, okay, 1 MB is just nothing for me. But if you go at a massive system, and what Ethereum facilitates is you just keep one instance of your code on the blockchain and everyone will follow that. Okay, so that's the beauty of it. Ethereum makes the entire Ethereum network as one whole computer that is on the internet, accessible, universal across everywhere. Okay, do let me know if there are any conceptual questions in this, because this is the start of Ethereum and programming on top of blockchain. So it's very important you can have conceptual clarity on this part. Any questions? Okay, I'll just briefly run through it again for clarity. Uh, Ethereum blockchain. Ethereum blockchain is like a 8-bit computer which is accessible by anyone on the earth from anywhere, irrespective of yes. So the code can be used by anyone in the Ethereum network, Ethereum blockchain. So let me go. Let me just show you one contract. We'll create one contract. So remix is the ID to use make the contract. Uh, it's a web-based ID, and I'll be creating on Rinky by testnet of Ethereum. So let's say this is a contract that I have written. This is a contract that I have. Decentralized network is like BitTorrent, that all nodes are independent. All nodes are independent. And all nodes act, but act in synchronously. That is a decentralized network. Centralized network is like you have a client server architecture is a centralized system, but decentralized network is the whole network, which is set of small nodes, but acting in cohesion. That is a decentralized network. Okay. So this is a piece of code that I have written, and we will just compile this piece of code using Solidity compiler 6.6, and the code is compiled. I'll be using injected web3. It will use my Rinky address, and I will deploy this owner contract onto Ethereum network. So this contract is deployed. Contract deployment is in process. Contract deployment is in process. I can see this transaction. This transaction is getting mined at this point. The block is not associated, or the timestamp is not there. Then moment it would be mined, it would take 15 seconds or so to mine it. Yes, it is mined. This transaction is residing in this block number, and this is the contract address for it. Now, when I go onto this contract address, I will be able to see a bytecode. I will be able to see a bytecode. That this bytecode is representing this particular code, and anyone on the network would be able to access this particular piece of code. So now, doesn't it make it like really interesting that if you solve a very critical problem, and there is only one piece of code across the internet for your application. So what it means is I can have my Uber app running on some other server, but everyone will fetch the information of identity from a single source. Similarly, if I'm having, let's say, Uh, Similarly, your financial instruments, you can have it from a single source. How many of you play games in your, like Fortnite or so? I'll give an example for Fortnite in that case. Anyone? Okay. So CSGO, do you have collectibles like skins or something of that sort? Yes. Okay. So in CSGO, what if you made a collectible in CSGO and put it on this blockchain registry, and that can be accessed by any other game, including Fortnite, PUBG, etc., etc. Or let's say your CSGO skins are put on the blockchain, and you can access it on other games. So won't that be cool? Exactly. So you can have a cross-platform integration from such a system. So that is like a game which is made by Sierra can have integration with a game that is made by EA. So similarly, such applications can be built using blockchain. Now, just a second. Similarly, such applications can be built using blockchain, and you can have the access of those code or the access of multiple systems simultaneously with you. Okay, let me know if there are any questions till now. Okay, okay. Now let's just go and interface with the blockchain. We have deployed this contract, and this contract is residing on this address. With that address, we can see it on the ether scan over here, and I can change the owner, and I can set some rules onto the system. That these are contracts. You can have a certain set of rules onto the system, wherein only some people can access the only some people can only the required address should access that function. So as in security you have a limit that in security you have a point that you need to block an access to a person for a function. That you can do over here in Solidity, wherein you can specify that particular parameter that this modifier should be a owner. Then only this particular function can be executed. If this guy, the person who is sending the contract, is a owner, then only you can execute the function. Else you can't be able. Else you will not be able to execute the function. Okay. Yeah. Do let me know if there are any questions before I go into the tooling part. Okay, so you have you tell us more about. Yeah, I'll be talking about that in tooling part. That how can you deploy contracts? You can use Remix, that is the ID remix.ethereum.org, to develop the contract. If you need, you'll need MetaMask as a wallet. This is a wallet. MetaMask is the wallet. Then you would need something known as faucet. Mm, faucet.rinkyby to get you follow this process to get testnet rinkyby ether. So if you make a tweet with your address, this is your address, you put your address over here, make the tweet, you copy the tweet, copy the tweet and paste it over here, and then you say give me 18.75 ether. They will give you 18.75 ether for test net only, not the mainnet. Mainnet ether are costly. Mainnet ether are live network. So mainnet is different, testnet is different. Okay, make the tweet and copy the tweet URL and post it over here. You will get the ether, testnet ether, and you can use injected web3 provider and over remix. Now I'll be moving on to tooling part. Tooling part, truffle. Truffle, truffle, not these truffles, these truffle. Truffle condenser. So this is a suite. Truffle suite is basically a suite that is used to develop the contract, write your contract. If you use Truffle suite, let me go to this part. I will open one of my project where I have. These are some contracts that I have written. And when you install Truffle suite, you'll have to install Truffle uh, using this part. Once you install Truffle, you will go through installation process, and then post which you will be creating a process, creating a project, compiling contract, migrating, compiling contract. You'll have to use something. Just a second, let me close this. Yeah, you'll be writing your contract in your contract folder. You'll be specifying all the contracts over here. And these contracts are to be written in the Solidity language specification. Uh, and the Solidity language specification, you can get it on Solidity documentation. So Solidity documentation, you can, this is a site for it, 6 point, use the latest version of Solidity compiler. These are details as to how do you write a Solidity, a code in your Solidity language. And if you write it correctly and adhering security requirements in a correct manner, then you will be able to compile these codes that you have written. I have written many such codes over here. Uh, all these codes I've written it, and then using truffle compile you'll be able to compile the code. And once the compilation is done, and there will be some errors right now because I'm working on this piece of code. uh, Once the contract is compiled and all, then you'd be able to migrate it using migration scripts. That these are the migration scripts for the code, that how do you want to deploy them. And post migration, you can write your testing code on top of it, that how do you want to perform testing for those contracts that you have written. Moment the testing is complete, you can have the documentation being generated and the security audits being done on top of it. So your tooling requirements can be handled off by Truffle. Truffle is a main suite to interface with, to write the contracts, and to interface with the contract from your front end. You will need something like Web3 JS. Web3 JS is a JavaScript library which can interface with your Solidity contract and your entire Ethereum blockchain. It can also integrate with your Web3 MetaMask wallet. So if you install MetaMask wallet, by default you'll get a Web3 instance on your browser. Okay. So moment you have this Web3 instance on your browser, you can interface with your entire Ethereum blockchain system from here only. However, the MetaMask wallets would give you a limitation on events, which gives me a lot of problem. Uh, event handling part, but you can always have a browserified version of Web3 along with it on the side. Is there any other questions on this? Do let me know because I think I went too fast with this. Okay. Uh, yes. Um, this is like it would take a lot of time. Right now, if I show everything, it would take around about 6 hours because this is too much knowledge inside it. Uh, because there are many small caveats associated at each point of development. So you can have security issues, you can have testing issues. Sometimes you'll write the test cases, but test cases would not work as you want it to work, or what is the issue you'd have to figure out over there. Then sometimes in migration, you'll have some issues. Like migration files will not run in sequence over there. Also, your Solidity code may sometimes give you nightmares if you have not written them correctly and understood them correctly. Uh, the important tool that when you're writing your Solidity code is Surya. Surya Solidity. This is a very important piece of code. It gives you a graphical visualization of your inheritance within your contract. Just like in C++, you have classes that are inheriting, classes which are you have classes that are inheriting. In Solidity also you have inheritance and other such object-oriented coding principles attached. So it's way more deeper than just for a 2 hour class. From here you can have something like this, that is the dependency map. So this is a APM registry is one contract. APM registries have these many small functions inside it, and they are talking to other contracts, and either they are inheriting those or not inheriting. So that all things you can derive from Surya. So Surya is basically a documentation generator, automated, but it gives you a clear picture of what is happening with your code. The moment you have a clear idea of your code, then you can function very easily with it also. Okay. Is there any other questions? And yeah, I'd like to see some interesting applications of blockchain. Anyone that some interesting live cases for blockchain applications that are in out there. Okay. Uh, let's look at one very interesting area, that is CryptoKitties. CryptoKitties. This is a game where you can collect. You can just like you have something. This is a collectible, a digital collectible on the internet itself, wherein just a second. Okay, yeah. Before I go into that part, uh, just a second. Like, what is the use of creating a project? This might be like why we create it. Uh, the, the utility of Ethereum is very interesting. It is like it gives you a 8-bit, it gives a universal computer without actual physical location. So if you look at the definition of Ethereum on Wikipedia, it is like the internet computer. So what it means is the entire network. In the current computation situation, your system is your computer. The processor is held with you. Okay. In Ethereum, the entire network of Ethereum acts like one computer and has one single state. So what happens is the entire Ethereum network is having one single state. It can store n number of information with it. And it is like the entire internet is as one computer. Okay? It is not small computers, but one hive. It's a hive of a computer which is acting, hive of small systems acting like one mind. It is very important from that perspective to understand Ethereum, that all the different nodes of Ethereum network are acting as one system. That is why it is different, and that is why the applications of it will be different. So now, as I told earlier, that your skins in CS:GO can be traded in World of Warcraft, or let's say Call of Duty. So World of Warcraft guys will have one server of Ethereum running on their system, and the CS guys will have one server sitting on their system. And all these companies have come to a common agreement for selling skins on their respective platform and cross utilization of these skins. So if you want to use your skin in CSGO in Call of Duty, you will have to pay one Call of Duty coin. If that arrangement is made, then Call of Duty would be in a profit situation. Now this is the logic behind it. That what if five parties come together and share a system? And that is the entire utility of Ethereum. That what if let's say what if five banks have come together and started launching a coin in a private manner itself. So that makes a different utilization case. What if let's say you are having KYC information being shared, as a user you are sharing your KYC information with 30 different parties. What if you are putting it on a common network which shares it to all the parties that you need it? In that case, that makes more sense. So similarly, you have like another case is you have to register to many providers, uh, many websites with your passwords. What if you just stored your password at one point on the internet, one point on the Ethereum network, and you're registering over and over from that password only? So that these are the utility for Ethereum. Now there are many use cases of Ethereum. So you can look at this site. There are many interesting state state of dApps is a site which is a list of all the Ethereum based applications that are out there. So there are some storage space. Storage is a site where you can lend your storage space. Let's say you are having 2 TB of storage space on your computer. You are lending it to someone to store their data. Right now, Google charges from $30 for 5 GB of data space. Now you can start lending your data space to people and start earning money out of it. But that earning would be very minuscule at this point. Now then there is this Sentinel VPN. You can start offering VPN services and you can start earning money for renting your VPN space or your your broadband provider. So there are some very interesting applications out there. So then there is, let's say, voting portal. Then you are having Nash tokens. There are many such applications on top of it. Compound algorithmic money market. Algorithmic money market. It grew by 3,000% in last 7 days. These are very interesting but very different proposals that are out there. However, I would suggest, I would request you to look at state of the dApps once to understand what all kind of applications are there in the public domain for Ethereum blockchain. In finance, there are many applications which are already being used by various banks and organizations. Okay, yeah. I'll keep the floor open for questions, and I'm pretty much done. Do let me know if you have any questions or any comments or anything, and do let me know if you've not understood. Also, I'm very glad to help on each of them. Okay. Yeah. Yeah. You can lend your hardware. You go to Sentinel. Let's look at Sentinel. So Sentinel, with which you can become a hub, if you become a Sentinel hub, then people will do decentralized chat and decentralized VPN from your system. Same with storage, decentralized cloud storage. If you are having a decentralized cloud storage, means you are renting your space to create a decentralized cloud storage space, and for each sector of your hard drive that you are lending, you are getting some amount in that particular currency. This is just one example. These are some examples of it. But the thing is, staying with such networks is you have to be very vigilant with what is happening with the network. If things are not happening good with the network, you should move out of it. And if things are happening good with the network, you should stick to it. You become a host. If you become a host, then you can start earning. These are next generational markets that are being made on top of Ethereum, and these are not using any environment of Google or any such players like that. Okay. Yeah. Any questions? Okay. No, you don't need it to access these sites. They're public. Yep. Okay. Shall we wrap up for the day? Or if let me know if anyone has any questions. Or do you want me to? If anyone has questions, do let me know if you want to go on to any specific details of the area that you want me to dig into. Okay, okay. Okay, yeah. Let's call it for the day. And you know where to reach me. My email ID is harsh.patel54 at gmail, and I'll be there. Okay, cool. Thanks, everyone.
Hello.
Yeah.
Okay. So I hope that session was really good. Anyone else? Do you have any more questions to ask him? Okay, so then on behalf of EdgyHack, I'd like to extend a really hearty vote of thanks to our speaker, Harsh Patel, to spare time from his busy schedule for us. Today, we had
Hmm.
an opportunity to hear about your thoughts. This will surely encourage us for our future events. Thank you, sir.
Thanks. Thanks. Thanks, everyone. Bye bye.